So we are on page 95, time 5 in unit 2. There we go. Yes. I will be coming around and checking it once we have done this. So while you're working on this stuff, I'll come around and check. Okay? Because, yes? Yes, I do. Anyone else? Unit 2 relevant package? No worries, it's all good. This is just if you didn't bring your unit 2 today. If you have unit 2, then yeah. Unit 2 was white. Yeah. Okay. So we are on page 95. In unit 2. Do you have your unit 2 book with you today? Excellent. Okay. That's unit 3. You both? Cool. Cool, cool. So last couple days we looked at molecules. Yes, and they looked kind of like these little guys here. Yes. We looked at atoms, which are pretty straightforward because atoms just look like that. Yes, those were 2 of the types of particles. So we have looked at atoms, we have looked at molecules. Today we're going to look at ions and formula units. Okay? So back to page 95. Yes. Yes. All right, so ions have an electrical charge. That's what makes them different than atoms and molecules. And an electrical charge could be, what are the 2 electrical charges, 2 possible electrical charges? Yes, positive and negative. And why are things positive or negative? Why would an atom be positive or negative? Yeah, it either has more electrons than protons or more protons than electrons. Okay, so it'll have an electron, an electrical charge because it has either lost or gained electrons. What does the prefix mono mean? Mono means 1. And therefore monatomic ions have 1 atom, monatomic, 1 atom. What does the prefix poly mean? Poly means many. So if you have a polyatomic ion, that's going to contain 2 or more atoms that are bonded together. Now, we know because it says here that cations have a positive charge. I would like you to tell your partner how you can remember that cations are the positive ones. Yes. Yes. How can you remember that cations are positive? Because cats have paws. Yes, we can have our little cat here. And they have paws. There we go. What type of element forms cations? When I say type of element, what are the two main types of elements? Metals and nonmetals. So is it the metals or the nonmetals that make cations? It is the metals, yes. Now, anions, of course, are negative. And tell your partner somehow you can remember that anions are negative. There's a couple ways you can remember. You might have a negative ion. A negative ion is an anion. Or you might say anion sounds a little bit like onion. And what do onions do? They make you cry, and maybe crying is a negative thing, although not always, but sometimes crying can be negative, okay? So those are anions. What type of element forms anions? Those are our nonmetals, yes. Okay. So cations are positive, anions are negative, and polyatomic ions there are polyatomic cations and there are polyatomic anions. And we have our little pictures here to help us remember. We have our cat having paws, and we have a little crying onion. I was so happy when I found these little pictures because it's like the little cat's showing you his paw, and we have a crying onion. So there we go. Now, when we're going to draw a picture of a cation, what is it about these pictures that makes them different from atoms? What about these pictures makes them different from atoms? Tell your partner. Yes, they have charges. So you can either write the charge inside the atom, or you can write the charge on the outside. It doesn't really matter, okay? And same thing if you've got a negative one. If you have an anion over here, you can either write the charge inside or you can write the charge outside. Now we have some polyatomic cations, and here we have NH4. What type of element is hydrogen? Is hydrogen a metal or is it a non-metal? It's a non-metal. Nitrogen, is nitrogen a metal or a non-metal? Nitrogen is a non-metal. when we have a nonmetal plus a nonmetal, what kind of bond do we get? That is covalent. Excellent. Okay, so this is interesting. Within an ion, there can be covalent bonds. Okay. You guys are doing really well. My other block was like half asleep, and they were like, I don't know. And we just did this one, then I went over here and I was like, okay, this one is a nonmetal, and this one is a nonmetal. So what kind of bond is that? Just done this one, right? But like, I swear to God, they were all still asleep from spring break because they were like, it was quite funny. Covalent bond. Okay. Now, we might actually take two polyatomic ions and put them beside one another. So I'm going to draw a little NH4 down here. N, H, 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 and that has a positive charge. And I'm also going to draw an OH, a hydroxide ion, an O and an H. Okay. So this is ammonium hydroxide. That would be the compound name. What type of bond do we have in between the N and the H? That is covalent. Type of bond do we have in between the O and the H? That is a covalent bond. There is also a bond in between the ammonium ion and the hydroxide ion. What type of bond is that bond that's in between the two ions? That is an ionic bond, yes. In between two ions, you have an ionic bond. Shocking, right? Okay. So it's interesting because when we have the compound ammonium hydroxide, we have both covalent bonds present and ionic bonds. But we would call it an ionic compound. Formula units. A formula unit is neutral. What is the net charge if something is neutral? 0. So our net charge is equal to 0. It is a single neutral unit of an ionic compound. And since it is made of ions, that means that the positive cation must cancel out the negative anion. The charge of the cation and anion cancel. Actually, I guess I should put cation with a bracket S and anion with a bracket S because you might need more than one of them. Cations and anions do not exist on their own. I cannot go and get a pile of Na plus ions. If I had one Na plus ion beside another Na plus ion, what would a positive ion do to another positive ion? Oh, I heard something. Repel, they would repel. Essentially, you would get a big explosion if you managed to get them in one place, okay? The other thing is that the sodium ion, positive one, had to have given its electron to somebody else. So there has to be somebody who took the electron. So there has to be an anion there. And so when we have our positive and our negative ion together, that is what we call a formula unit. However, ionic compounds do not normally exist as formula units. They normally exist like this. What is this thing? This three-dimensional structure. That is a crystal lattice. Okay, so they normally exist as a crystal lattice. And the key thing about a crystal lattice structure, an ionic crystal lattice structure, is that we have alternating positive and negative ions. So when you're looking at the structure and you're like, is this an ionic crystal lattice? You can look and you can say, oh, look, it alternates positive, negative, positive, negative. Yes, alternates. It's kind of hard to draw, kind of harder to see it in the three-dimensional structure, but if we take a simple two-dimensional slice, it's really easy to see that it goes negative, positive, negative, positive, negative, positive, negative. Yeah, alternating. Now, what do we call it if I took this single little bit here? What's that called? That is a formula unit, yes. And it is extremely unlikely that you would have a formula unit because the chances of having a single sodium atom and a single chlorine atom with no other sodium atoms and chlorine atoms around, so unlikely that those two would just be hanging around together, especially because chlorine in nature always comes as Cl2, it comes with a little partner, okay? What kind of force do we have in between the sodium ion and the chloride ion? What's going on here? In between the sodium ion and the chloride ion. That is an ionic bond, yes. They would repel each other and explode. Yeah, it's a different thing. To be honest, you cannot get a positive ion without there being negative ions around. It does not happen. Yes, it's not an electrical charge for magnets, it's a magnetic force. So instead of having positives and negatives, you have norths and souths, but it works the same way. And it's actually a really good way of like actually feeling what the electrical charges would feel like, right? You can try pushing the two north poles together and they're like, oh, you can't make them touch. And then you flip them around and then it's harder to pull them apart. And yeah, exactly. Yeah. Now, maybe I'll even make life a little bit more difficult for you from time to time. And I might say, if I show you this thing here, it is not labeled with positives and negatives. But Can you see that it is an alternating structure? And if you can see that it's an alternating structure, you can assume that it alternates positive and negative. And if you assume it alternates positive and negative, then what type of substance is this structure here? What would we call this structure? Hmm? Don't think too hard. What does it look like? Looks like an ionic lattice. It is an ionic crystal lattice. So you can assume, even though I haven't drawn them in, that there would be a negative here and a positive here and a negative here and a positive here and a negative here. Okay, even though they are not drawn in. Similarly, if I give you a two-dimensional thing where we have an alternating structure, therefore you can assume it alternates positive and negative. And if it alternates positive and negative, what kind of a structure do we have? An ionic crystal lattice, yes. Okay. With a formula unit, I will always have to put in the positive and negative, because if I don't, you can't tell. Like if I was just to draw it like this, that would be a molecule. You would not be able to tell that it is a formula unit unless I actually put some charges on there. If I don't put the charges on, you would have to assume it's neutral. But with the ionic crystal lattice, you can see the alternating pattern and you can make an assumption. All right, so that is today's content. You guys are going to work on pages 97 to 101. Okay. And while you are working on that, you can, of course, call me over to ask any questions that you might have. But I'm going to come around and check your Unit 3 homework. Okay. Oh, also, while we're here, your tests have been marked. Your labs have been marked. So if you wish to check your grade, you can look on MyEd. Okay, they're up and posted now. If you got below 60% on the test, then you can come and do corrections, because I would rather not have anyone fail the course. Yes, it would be nice for everybody to pass. So if you did not so well, you can come and do corrections and bring up your grades somewhat. Okay? So this is the homework. Block 3 is doing a survey tomorrow. You guys will be doing a survey in your block 3 tomorrow because we haven't done enough surveys, apparently. We must do more. Block 3 is also doing this because they won't have time to work on this tomorrow. Okay? But you guys don't have to do it. If you want to, you can. Okay? But you'll have time in class tomorrow because, yeah. There you go. It is on Teams. It says Spring Break. Yeah. Yeah. Yeah, it's all good. Don't worry. That's why we need the extra practice. Yeah. Yeah. And no worries, we'll go over that. Yeah, yeah. You're supposed to. Oh, good. Okay. Yeah. You're all right. You're surviving back at school. Did anyone have any questions on the stuff you're working on? Yes, there's a lot of labeling, right? Yeah. So folks, this week, don't forget you're going to be bringing both your workbooks, right? Unit 2 and Unit 3.